gave a couple of TED Talks, and I think I watched his TED Talk even before I met Blaise in person. So looking forward.
Thank you so much. We've just come off of 3 fantastic talks, and in many ways, what I would like to talk about is basically a redux of the last 3 talks that we've just heard from Golan, Rebecca, and Doug. The risk in the mirror or the new influencing machine is a title that will hopefully make more sense as we go a little further into it. Sorry, are we okay? Yeah, sure. Good. So I want to begin with just with a very quick sort of historical recap of the science of neural networks and the technology of neural networks, and point out that these things began at the same time as computational neuroscience did. So we tend to think about computers and neuroscience as very distinct fields, and the fact that nowadays the neural nets that we're using to do all of these wonderful things look vaguely modeled on neurons as sort of a modern thing. But the fact is that those 2 fields began at the same time. This is a drawing that Santiago Ramón y Cajal, the great neuroanatomist, made in 1900 of a visual cortex. And this is a diagram that the computational neuroscientists McCulloch and Pitts made in 1947 of this same piece of visual cortex, imagining what kind of neural network would be required in order to produce translational invariance in scene recognition, which is exactly the thing that convolutional neural nets do, by the way. All of the details of what they were imagining was going on here in this circuit, which they were imagining electronically, are wrong. But one of the things that's sort of interesting is that they've represented pyramidal neurons in visual cortex using these symbols, which they kind of wrote about in their earlier paper in 1943 as they're pyramidal neurons. Like if you go back to the Ramón y Cajal, you can see those sort of pyramid-shaped neurons in visual cortex. And they claimed that they were doing logical operations, and they made an equivalence between those and logic gates. I'm pretty sure that this is where the symbols for logic gates actually came from. That loop at the end of the neuron is an inhibitory synapse, and I'm pretty sure that that's where the loop at the end of logic gates indicating the not also came from. So these were very much, sort of twins separated at birth, the digital computer and the neural network. And those of you who know about Alan Turing's original papers, Intelligent Machinery, know that he was after making machines that could do what brains do. And those neural network those neural network problems were attempted way back in the 1950s by Frank Rosenblatt and others. This was the perceptron. Of course, at that time, they were doomed to failure because we had neither the computing power nor the data to be able to train such networks. But these are not new ideas. This was all back in Turing's original papers and even earlier. Nowadays, the same kinds of neural networks can do exactly the sorts of things that we've all been watching today. This is a neural net that classifies different types of birds and does it in real time on a phone. So here a serial computer on the phone is simulating a giant parallel neural network because our serial computers have become so fast that they actually can do that. Of course, the devices of a few years from now will be doing these kinds of parallel neural network computations natively. And I suspect, and many of us suspect, that the majority of computing cycles on Earth in a few years' time will be on processors that are natively parallel and neural, as opposed to following the sort of Turing and von Neumann serial architecture. You can also take those same networks and invert them. And this is where Deep Dream and all of those kinds of things come from, which you've all seen many examples of. This is that same species recognition network inverted, with the idea of bird going in the output and sort of the input being reconstructed. And you get these kind of beautiful visualizations of this kind. This one came from Mike Tyka. And you can see that the pose, and many of these category visualizations things have the kind of ambiguity about the pose or the position of the image synthesized, because, of course, the network is designed to work under conditions of ambiguous position or pose. It's designed to resolve that ambiguity. So when you run it backwards, unless you do some very special things in the optimization, you'll get this kind of cubist stuff. This is another much more recent piece of Mike Tyka's, which we saw a still from earlier, and I'll now show you the motion version. This is FaceNet being run backward. So these are all, this is all purely synthetic faces, sort of a wander through face space being reconstructed as an image. And something about the way Mike did this particular network generates these rather beautiful, almost painterly kinds of effects during that wander through face space. So there's something beautiful, there's something uncanny, and I think there's something. I don't know. To me, this maybe hits. I don't know if it hits the masterpiece spot, but there's something here. And these are all up on YouTube, by the way. This is one of the pieces that Ross Goodwin, one of our artist collaborators, way back more than a year ago, made. It's a camera mounted on a chest strap that takes a picture, and then an LSTM generates poetry out of the picture on a piece of thermal printer paper. And you know, the poetry is kind of like almost passable if you don't read too much of it. But of course, you know, what's interesting about this isn't that the poems themselves are good poems. It's you know, as as Golan was saying, it's not about the poem is not the art. It's the performance of this piece that's interesting. It's the meta art, if you like, and I think as meta art, this is a pretty interesting piece. Now, in some quarters of the art world, that has caused a certain degree of anxiety, and we've talked a little bit about that here today. That anxiety is reminiscent in my mind of some of the anxiety raised by Walter Benjamin back in the early 20th century, when he was writing about the mass reproduction of art. The idea that art was losing its aura because we had all these new technologies that were able to take an original and reproduce it endlessly, or new media like film, like cinema, in which the idea of an original doesn't even make any sense. And so, you know, how can you think about art as a status symbol if there's no original, and if anybody can see it, and anybody can have a copy, and it's no longer this thing that confers status by being hung on the wall of your mansion? So, you know, for Benjamin as a Marxist, this had all kinds of implications, both in terms of the economics of art production and the economics of art ownership, and the democratization of art as a cultural expression. And in many ways, I see some of that same kind of moral panic nowadays around AI, not only with respect to art, but with respect to all kinds of other perceived risks about human exceptionalism and even about human existence. And of course, the ultimate kind of expression of that anxiety is in this book by Nick Bostrom, which I think is the only bestseller in philosophy of the past century, as far as I know. I'm kind of reminded in reading that book of The Influencing Machine, which, for those of you who don't know, is a wonderful paper written by Dr. Viktor Trausk in the early 20th century. He was a student of Freud's, describing a kind of paranoid schizophrenia and a sort of symptom that came up a lot among a certain kind of paranoid schizophrenic, in which the patient imagines a machine that's outside themselves, and that machine is able to read their thoughts and control their behaviors. You know, all the kind of classic, like watching the TV, you know, believing that the TV can read your thoughts or is influencing your imagination, is sort of the modern version of this influencing machine. This particular drawing was made by Jakob Mohr to illustrate his idea of what was happening in his own mind. And of course, you know, what this is all about is kind of imagining some outside thing that really is a part of yourself. You know, the influencing machine, of course, isn't distinct from his own mind, but his anxiety came from othering his perceptions and his impulses in this way. In Trausk's paper on the origin of the influencing machine and schizophrenia, he wrote, "The schizophrenic influencing machine is a machine of mystical nature. The patients are able to give only vague hints of its construction. It consists of boxes, cranks, levers, wheels, buttons, wires, batteries, and the like. Patients endeavor to discover the construction of the apparatus by means of their technical knowledge, and it appears that with the progressive popularization of the sciences, all the forces known to technology are utilized to explain the functioning of the apparatus." And in what I thought was kind of a fun a fun moment of insight later in the paper. He points out that the machine serves to persecute the patient and is operated by enemies. To the best of my knowledge, the latter are exclusively of the male sex. And this sort of genderedness of it, I think, is sort of interesting, because in my mind, these kind of paranoid ideas go hand in hand with ideas about domination and about colonialism as well. There is a sort of box, an inset box in Bostrom's book that I thought was extremely telling. What some people don't know about Nick Bostrom is that before he was an AI philosopher, he was a simulism philosopher. So he played around a lot with these ideas that we're actually living in this giant simulation, and that nothing is real, and that's the more likely thing, that there is such a thing as reality. And the size of the cosmic endowment, which is literally the name of this box, kind of combines his previous and current sort of philosophical obsessions in a pretty interesting way. It says, consider a technologically mature civilization capable of building sophisticated von Neumann probes. If these can travel at 50% the speed of light, they can reach some 6 × 10⁸ stars before the cosmic expansion puts further acquisitions forever out of reach. At 99% of the speed of light, they could reach some 2 × 10⁻20 stars. These travel speeds are energetically attainable using only a small fraction of the resources available in the solar system. Many more orders of magnitudes of human-like beings could exist if we counted its digital implementations of minds, as we should. This would mean that at least 10⁵ human lives could be created in emulation. Now, he's writing this in order to make clear, how big the stakes are if we fuck it up. But what I find interesting is that this is like the ultimate colonial project. It's literally colonialism limited only by the laws of physics. And it strikes me as not the utopia that Bostrom is imagining, but as an absolutely horrible dystopia. This idea of man's domination of nature is an old thread. It's an old obsession in Western society. I'd like to give you maybe one of the texts of this. I am come in very truth, leading nature to you with all her children, to bind her to your service and to make her your slave. So may I succeed in my only earthly wish, namely to stretch the deplorably narrow limits of man's dominion over the universe to their promised bounds. This rather chilling quote comes from Sir Francis Bacon in 1603 in an essay called The Masculine Birth of Time, or the Great Instauration of the Dominion of Man over the Universe. So a direct line from Francis Bacon to Nick Bostrom. In my opinion, this mindset, this point of view is sort of the enemy. This is what we have to overcome. And I much prefer the kind of feminist reading that Kember and Zielinska give in their book, Life After New Media, in 2012. If we do accept that we've always been cyborgs, it'll be easier for us to let go of paranoid narratives that see technology as an external other that threatens the human and needs to be stopped at all costs before a new mutant species of replicants, robots, or aliens emerges to compete with humans and eventually to win the battle. Seeing ourselves as always already connected, as being part of the system rather than as masters of the universe to which all beings are inferior, is an important step to developing a more critical and a more responsible relationship to the world, to what we call man, nature, and technology. So the sort of augmentation viewpoint that we've been talking about, as opposed to the domination viewpoint in which we're either slaves or masters, I think is a much more interesting way of thinking about it. Letitia Tsunami in Rebecca's talk made a very similar statement, I thought. So, what should actually worry us if it's not killer robot alien influencing machines? Well, it's the fact that there is no influencing machine, that it's actually all us, and we are the ones who should worry ourselves, as Golan was saying. The current way that these things work is that training data are harvested. That's often done with big data or with services. Algorithms are programmed. That's machine learning. Media get classified, filtered, aggregated, generated. This could be newsfeed kind of stuff. It could be deep dream. It could be media synthesis of all kinds. And that in turn programs people as well, because a lot of our experience of the world, of course, is mediated in these ways nowadays. And then there are all the feedback loops that emerge from all of that happening, right? As we consume, we also produce, and all of the things that we get, we regurgitate and become the inputs to the next cycle, the next turn of the crank. So while a lot of the kind of AI AI worriers talk about the value alignment problem, by which they mean, how do we make AI that has human values, that embeds human values, as opposed to some kind of alien values? Well, AI does embed human values, because all of the different forms of AI that we've been talking about today and that we know about are all trained on us. They are actually a mirror. So it is human values that are in there. And the problem is that when we look in that mirror, we find that our own values are problematic. So, you know, Golan already mentioned automated inference on criminality using face images, the Wu and Zhang paper, not peer-reviewed, from back in November 2016. How many of you already know about this paper? So this is an awesome, you know, it's an awesome conference when the majority of people raise their hands. How many do not know about this? Okay, this is like 2, so I can't even do the experiment that I wanted to do with you. But they write, you know, we're the first to study automated face-induced inference on criminality free of any biases of subjective judgments of human observers, which of course is silly, because the training data they use to figure out, you know, whether a face is quote unquote criminal or not quote unquote criminal is human judges having decided this. I gave some kind of version of this talk to some students once before, and asked people to raise their hands if they thought it was the top row or the bottom row, and the results in the room were the same as for their algorithm, namely that 90% of people without any priors will assume that the top row are the criminals, and 10% the bottom row, which is basically what the deep neural net said as well. There are plenty of reasons to understand why that's going on, to do with things like the smile. Maybe it's the white collars. Maybe the ones on the bottom are actually white-collar criminals. I don't know. But there have been lots of interesting analyses that demonstrate that, of course, you can't read criminality from the face. That shouldn't be a surprise. Controlled studies have been done. Alex Todorov and his colleagues at Princeton have explored these questions. People's character is absolutely not something that can be read from the face, but people's prejudices can absolutely be read from the face. And what was revealed by this study is not the thing that the authors thought was revealed, which is that somehow there is a typical criminal face, but rather that judgment about these issues probably suffers from pretty serious human bias among Chinese judges. This is Alex and colleagues' sort of a statistical model of a quote-unquote trustworthy face on the left and an untrustworthy face on the right, averaged over a lot of trials from human subjects in a psych experiment. And you know, you see some pretty interesting things, like the more feminized trustworthy face and the more masculinized untrustworthy face, and the more smiley versus more frowny resting expression. There isn't really a politics of this, like there aren't support groups for people with untrustworthy faces, but it's likely that they suffer from lifelong discrimination that is you know, possibly as serious as the discrimination that arises from being born of the wrong race or something in the U.S. So maybe there will be an identity politics of this at some point. I don't know. This kind of stuff is getting productionized, is getting turned into technologies that are being made available by companies like this one in Faceception, Israeli startup that purports to be able to tell from a face image whether you have high IQ, are an academic researcher, are a professional poker player, a terrorist, or a pedophile. And Michael Kosinski, by the way, is also apparently a technical advisor for this company, as well as having been involved somehow in Cambridge Analytica's founding. They claim in their video on their website that one of their early customers, by the way, is Homeland Security. It's interesting. Kosinski's new paper of a couple of weeks ago is about guessing whether you are gay or not based on a picture. Of course, the pictures that they harvested were pictures from I think it was OkCupid, or from some dating websites. You know, these kind of averages of the heterosexual and homosexual male and female face reveal some pretty interesting things about what might actually be going on in this orientation recognizer based on selfies. So you might notice that the gay guy has glasses and the straight guy doesn't. that the gay guy has either short beard or no beard, and the straight guy has has lots of beard. You might notice that the straight guy has darker skin, and appears to have a big chin and a small forehead, and whereas the gay guy has some more balanced facial features. You might notice that the straight female has lots of eyeshadow and the gay female does not. That there's maybe more makeup going on in the straight female, and so I just thought, like last weekend, that it would be interesting to test some of those kind of guesses, and ran a study with Mechanical Turk and 8,000 respondents, asking a bunch of yes/no questions, like do you identify as gay or lesbian? Are you attracted to women or men? Do you wear makeup or not? Do you wear eyeshadow or not? Do you wear glasses or not? And the results are pretty interesting. So this is a percentage of people who wear glasses. Those are error bars, by the way, and I've done it over age ranges, so you can sort of see the broad set of results. So this is opposite sex attracted men in blue and same sex attracted men in red, percent who wear glasses. These are actually quite a big difference. So maybe that's because gay men have worse vision. Same thing with women, by the way. Lesbians, or I should not say lesbian in this case. The question was, are you attracted? Are you same-sex attracted, either romantically or sexually? So women also wear more glasses if they're same-sex attracted. Probably that's because they like how they look in glasses better. So I also asked the question, do you like how you look in glasses? And you see a pretty big difference across most ages in men. So gay men like how they look in glasses more. And also same-sex attracted women like how they look in glasses more. So there's some interesting sort of style or social signaling things going on here. I also asked questions about facial hair, and the y-axis here is percent who have serious facial hair. What I mean by that is that they answered yes to any of mustache, beard, goatee, and no to stubble. Because it turned out when I began to look into the data in detail that a lot of gay men say that they have actually, like, I guess the kind of stubbly thing that I've got going on and that Jess has going on. So like and I'm now wearing glasses as well. So I suppose. But it turns out that serious facial hair is a pretty strong straight man tell, with the exception of this particular age range, around 40 to 45, which I'm provisionally calling the bear peak. Sorry. And then if you ask, I also asked, like, do you have a tan face? And there's a small but statistically significant difference across all age ranges in men. Straight men have more claim that they have more tan faces than same-sex attracted men. Why might that be? Well, I also asked, do you work outdoors? And turns out that straight men work outdoors a lot more than same-sex attracted men. Use makeup. So big difference between same-sex attracted women and opposite-sex attracted women, and women who self-identify as lesbian have an even bigger difference. So does this mean the stereotype is that if you wear makeup you're not a lesbian is true? No, I mean actually 50% do, but there's most definitely a correlation there. Eyeshadow. Same kind of correlation. So in other words, there are a lot of tells, and a lot of these things have to do with how you present, what you do with yourself in the morning, how you've groomed your hair, and maybe even with what angle you pick to take your selfie from. I mean, if you look at the straight man, Kosinski claims that it's about having I don't know, more prominent cheekbones or a bigger chin or something. But I think it's more likely that they take the photo from below, because as any wedding photographer will tell you, a man will look more dominant, or anybody will look more dominant really, if you shoot from below, and it'll make your chin appear to be bigger and your forehead appear to be smaller. And if you're shooting from a level, which, by the way, of course, that also probably has something to do with the relative heights of men and women, and where you want to be perceived from. You want to be perceived as tall and as dominant, and so these kinds of effects are certainly figuring in a pretty big way into whatever the neural net is figuring out, and the onus is really on some researcher to take these kinds of images under standardized conditions. maybe with a 3D scan or something, if they want to make a claim about the structure of your bones or of your face. There's not evidence in this study to show that that's the case. So I want to end, and I'm sorry, I know I've run a little bit over time, but I just want to end by saying that none of these are arguments against machine learning. It's actually the opposite. All of the behaviors, all of the biases, all of the prejudices that we have been talking about, or in some cases not biases and prejudices, but just how we present, what is the social signaling, how does all this stuff work? Those are things that machine learning allows us to hold a mirror up to, which is critical. How are we going to understand those things about ourselves? How are we going to introspect if we can't use machine learning and powerful technologies in order to understand all of that? The biases and the problems are not coming from the machine learning, they're coming from us, and these are the things that allow us to understand them. The problem is when we use those technologies to then launder our own biases and somehow do this influencing machine trick in which we pretend that it's other as opposed to a part of ourselves. And that's what we have to look out for. I'll end there. Thank you.
Thank you for the awesome talk. For the interest of time, we'll suggest the questions during the break. Thank you so much for Blaise. We're going to take a break until 3:40.